Hello students. Now we are going to see microcontroller. Microcontroller, I suppose Dr. Mohandas sir could have completed and could have discussed more about PLC and its functions, applications. Now the next important topic is microcontroller. Here we are going to discuss what is microcontroller, what is the difference between microprocessor and microcontroller, and then we will see the functionality of the very basic type of microcontroller, that is 8051, and then we shall move to its applications, and then we will see different manufacturers of microcontrollers which are in existence. So here, if you see in earlier days, two decades back, the process and control operations were totally implemented by the microprocessors only. So we had microprocessors, and we are going to attach the different peripherals to microprocessor, and then we used to get the control operations controlling different processes or different tasks. But nowadays the situation is totally changed, and it is occupied by the new device called microcontroller. Now we cannot call it as a very new device, but it is in existence for more than 10 years now. Microcontroller is such an important device in control operations. Wherever we have movement or motion, there should be controller. We need controller to control the motion in any particular application, or in any even in automobiles. The microcontrollers are playing a major role. The development is so drastic that we cannot find any electronic gadgets without the use of a microcontroller. So development is taking place even now. There are so many microcontrollers are coming up, like we have Arduino microcontroller, and these are all very latest controllers. And if you understand the basic microcontroller like 8051 from Intel family, and very easily can understand the other microcontrollers. So microcontroller is the key to embedded system design entrepreneurs and design engineers. So here, if you see the embedded systems, right? Without microcontroller, there are no embedded systems now at present scenario. So embedded systems are everywhere. It is used widely in most of the control operations, even wherever you find the sophisticated electronics applications, there embedded systems are playing a vital role. So we'll see what is microcontroller. It is a single chip computer or a CPU with all peripherals like ROM, RAM, IO ports, timers, ADC, that is analog to digital converters, etc. on the same chip. So one chip contains almost all the peripherals required to control a process or task. So, example Motorola, Ziglar, Intel, PIC. There are so many manufacturers. I will give you a brief list again. Microprocessor, that is everything is embedded on a single chip. So RAM, ROM, we have IO ports, everything. So that is microcontroller. Whereas here, microprocessor is a single chip without all those. So here we can say like this: all microcontrollers are microprocessors, but all microprocessors are not microcontrollers. So like this, you can differentiate these two. So whereas here there are no timers, there are no counters, and everything are external devices. It is a general purpose device, and additional external circuitry are added to make it a microcomputer. A microprocessor contains arithmetic and logic unit, that is called as ALU, instruction decoder and control unit, instruction register, program counter, clock unit, internal, it may be internal or external clock circuit. So it is normally an oscillator, reset circuit, internal or external, and registers. But the microprocessor has no on-chip I/O ports, timers, memories, timer counters, etc., etc. Whereas if you combine everything in a single chip, then it is known as microcontroller. So that is the basic difference between microprocessor and microcontroller. For example, 8085 is a 8-bit microprocessor. 8086, 8051, these are all microcontrollers. 8086. These are all 8-bit processors. In the other hand, if you see microcontroller, it is a very highly integrated single chip. It is a single chip only. It is also a 40 pin dual inline package. So on one side you will have 20 pins, on the other side you will have 20 more pins, which consists of chip, central processing unit, RAM, everything, right? Memory, different memory units, serial and parallel ports, timers, interrupt controller, everything is embedded in a single chip. That is why it is called as microcontroller. 8051 is a 8-bit microcontroller, and Intel 8096 is 16-bit microcontroller. 8051 is very popular type of microcontroller and very basic type of microcontroller. I will show you the block diagram. That is, this is the block diagram. You can see here. This is ALU. So now normally the difference between a microprocessor and microcontroller, ALU is a part of microprocessor, interrupt circuits, clock circuit, all this, stack pointer, accumulator, registers, timer and counter, I/O ports. These two are making a microprocessor into microcontroller, attaching these two. So program counter, these are all the internal parts of microprocessor, and it is a part of microprocessor. And attaching these two, timer control circuit, counter circuit, and I/O ports, that is input output ports, to the microprocessor, that brings you a microcontroller. Features of 8051 microcontroller: it is a 8-bit CPU, 16-bit program counter, 8-bit processor status word (PSW), 8-bit stack pointer, internal RAM of 128 bytes, special functions registers (SFRs) of 128 bytes, 32 I/O pins arranged as four 8-bit ports. So we have four ports. I will show you in a block diagram or architecture: P0 to P3, two 16-bit timers and counters, T0 and T1, two external and three internal vectored interrupts. So interrupts are directed interrupts here, and one full duplex serial I/O. So this is the architecture. I will show you architecture. The architecture of 8051 microcontroller can be understood from its architecture diagram that I will show you in next slide. It follows Harvard architecture. So another popular architecture is von Neumann. Von Neumann is not used here, but Harvard architecture is used with a RISC, reduced instruction set computer concept. So this is the instruction set is developed on this basis, reduced instruction set computer concept. It is nothing but very few instructions are lesser, not many instructions. involved. It consists of an 8-bit ALU, 8-bit PSW, A B registers, one 16-bit program counter, one 16-bit data pointer register, that is DPTR, 128 bytes of RAM and 4 kilobytes of ROM, and 4 parallel I/O ports, each 8-bit width. So this is the simple introduction about the architecture. I will show you the architecture. So here, this is the architecture. It is simpler than 8085 microprocessor. You have CPU and you have oscillator. Oscillator is giving the clock signals to all the peripherals attached to CPU, and it is controlled by a quartz crystal. It is generated by quartz crystal, and this is CPU. And this oscillator is required to make or to achieve or to bring a synchronization between different peripherals attached to microprocessor. And you have interrupt controls. You have external interrupts, 4K flash, 128 byte RAM, and timer and counter. So this is separate unit attached to it. And this is bus control, where we have two types of buses. One is address bus and another one is the data bus. And you have four I/O ports, and this is P0, P2, P1, and P3. All are bidirectional buses, so data can be taken in both directions. So this is simple architecture of 8051. So this is the pin diagram. This is the pin diagram. So this is the notch, and from here you have to start counting the pin numbers. It starts from left hand side. You should count in a counterclockwise direction, 1, 2, up to 20. So always 20th pin is the ground pin, and 40th pin is VCC. So out of 40 pins, 2 pins are power pins. That is 20 and 40 for ground, and VCC for respectively. So here, this is port 1. So port 1 consists of 8 pins, P1.0, P1.1 up to P1.7. So these are the 8 pins. And here, this is the reset pin, and you have RXT and TXT, and this is write and for transfer of data. This is the receiver data, and transferring the data, int not int 1 to interrupts, and we have t naught and t1. We have write bar and read. We have xtal1 and xtal2, and this is the port 3. So port 3 consists of these pins, and we have port 2. Port 2 is starting from 21st pin and ending at 28th pin, and this is actually the address bus. This forms the address bus. You have it is completely address bus. And you have one more, the upper or we can say lower address bus is with the P0 port, and it is a multiplexed bus. It is address and data bus, AD0 to AD7, that is connected through P0 port through 8 pins. And you have external enable, and we have ALE or ALE address latch enable. Or you can use it for programming. PSEN, this is program status enable. So this is another important pin in 8051. So this is pin configuration. So interrupts, it is a subroutine call that interrupts the microcontroller's main operations on work and causes it to execute any other program. So like holding one process and executing another process, that can be done using interrupts. So here the feature of interrupt is very useful in case of emergency operations. An interrupt gives us a mechanism to put on hold the ongoing operations, execute a subroutine, and then again resumes to another type of operations. So we can hold one process and we can go to other process. Again, we can complete that and we can come back to the original process. The microcontroller 8051 can be configured in such a way that it is temporarily terminates or pass the main program at the occurrence of interrupts. That is the main function. When a subroutine is completed, then execution of main program starts. So that is, it is like looping only. Bus Bus is actually it is a combination of number of wires, and basically bus is a collection of wires which works as a communication channel or medium for data transfer. So buses can be 8 bit or 16 bit also. These buses can carry 8 bits or 16 bits simultaneously. There are two types of buses. One is address bus and data bus. Address bus is a 16-bit address bus and transferring the data, and it is used to address memory locations and transfer the address from CPU to memory of the controller. And the data bus, it is a microcontroller. It is a 8-bit bus only. It can carry data to different applications. It has four addressing modes. One is immediate addressing mode. The instructions, the microcontroller instructions are classified, or we can say how instructions are processed while execution of program, and based on these four addressing modes. One is immediate addressing mode, bank address, or it is also known as register addressing mode, direct addressing mode, register indirect addressing mode. These are the four modes. Oscillator, it is an on-chip oscillator which works as a clock source for central processing unit. And if you see, the output pulses of oscillator are stable. It enables synchronized work of all parts of the 8051 microcontroller. Input output port, normally a microcontroller is used in embedded systems to control the operations of machines. Therefore, to connect it to other machines, devices, or peripherals, we require I/O interfacing ports in the microcontroller interface. For this purpose, microcontroller 8051 has four input-output ports to connect it to other peripherals. So timers and counters, 8051 microcontroller has 16-bit timers and counters. These counters are again divided into 8-bit registers. The timers are used for measurement of intervals to determine the pulse width of the signal. So pin diagram of 8051, it is the pin diagram that I have shown you earlier. It is a 8051 microcontroller is available as a 40 pin dual inline package deep chip, which and it works at 5 plus 5 volts DC supply. Among the 40 pins, 32 pins are allotted to 4 ports. Each port consists of 8 pins, P0, P1, P2, P3. Each port occupies 8 pins. The remaining pins are VCC, ground, XTIL1, XTIL2, RST, EA, and PSCN. These are the remaining pins. And here you can see quartz crystal, the XTIL1 and XTIL2, through these two, through capacitors. Using capacitors, the power supply, or we can say the oscillator is connected. It is connected to oscillator through XTIL1 and XTIL2. So 30 picofarad capacitors are used in the circuit. This is reset pin. Reset pin is an input pin, and it is an active high pin. Active high pin and active low pin. You might be knowing when active high pin on receiving one, that is active 5 volt supply, the pin is will activate the process. It is like a normal switch. And active low pin, when it is receiving nothing, it will be a active pin. When it receives some signal, then it becomes inactive. So that is active low pin. Here reset pin is a active high pin. When a high pulse is applied to the pin, microcontroller will reset it and terminate all activities. Upon reset, all the registers except PC will reset to 0 value and PC register will reset to 7 value. So that is 8 values. And the external access, EA is active low pin. Whenever you find bar here, then it is known as active low pin. It is external access. This pin is an active low pin and connected to ground when microcontroller accessing the program code stored in the external memory. So that is the external access pin. This pin should not be left unconnected. It should be connected to some input. And PSEN program store enable. This is an output pin which is active low. When the microcontroller is accessing the program code stored in external ROM, this pin is connected to OE output enable pin of the ROM. And ALE address latch enable. This is output pin which is active high. And when connected to external memory, port 0 provides both address and data. IA address and the data are multiplexed through port 0. ALE pin will demultiplex the address and data bus. So when you enable ALE, when you give signal to ALE, it demultiplexes address and data bus, and that can be used either data or address purpose. When the pin is high, AD bus will act as address bus. Otherwise, AD bus will act as data bus. So this is port 0, port 0 P not O2, P not 7. And this acts as a multiplexed bus AD not to AD7. It is a P2 P2.02 P2.7. It acts as only address bus A8 to A15. And P1 to P1 not to P17. This 8-bit 8 pins are dedicated for port 1 to perform input or output port operations. This P3 port, these are different interrupts RXT, TXT, everything are connected to P3 port. It is also a 8-pin port. So addressing modes of 8051. So as I said, these are the five indexing addressing mode is also another mode used here. The way in which data operands are accessed by different instructions is known as the addressing modes. These are various methods of denoting the data operands in the instruction. The 8051 microcontroller supports mainly five addressing modes, that is immediate direct addressing mode, register indirect addressing mode, and indexed addressing mode, very much like 8085 addressing modes. Applications of 8051 microcontroller. Some of the applications of 8051 is mainly used in daily life and industrial applications. Also, some of the applications are shown here: light sensing and controlling devices, temperature sensing and controlling devices, fire detectors and safety devices, automobile applications, defense applications. Some industrial applications of microcontrollers are industrial instrumentation devices, process control devices. Some of 8051 microcontroller devices are used in measurement applications, voltmeter applications, measuring and revolving objects, current meter objects, handheld metering objects. Some of the popular microcontroller manufacturers are this Intel, Philips, Atmel, Siemens, Motorola, Dallas Semiconductors, and Microchip, etc. etc. And there are so many new recent microcontrollers are also coming up. And when you compare all these manufacturers, these are the main manufacturers of microcontrollers. One is Intel, Atmel, Motorola, Philips. These are all very popular microcontroller manufacturers. And the books you can refer this Gonkar, Krishnakant. These two are very good books. You can refer for more information on microprocessors and microcontrollers. And there is the microcontroller, and Mohan Dasar will continue the remaining portions in this unit. Thank you, students.